to do is we're going to find sides and angles using trig. So we take a look at this first example. We want to find the missing variable in each of the right triangles. So in the first one, we want to find y. How can we find the value of y? Remember? Well, we can just use the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. Which one has to be our c? Well, yeah, our hypotenuse across from the 90. Then it doesn't matter. I'll make that a, make that b. So we plug our values in. We have 8 squared plus y squared equals 12 squared. What is 8 squared? 64. What is 12 squared? What do we have to do with the 64 to get y squared by itself? Subtract it. Move the 64 over. So we get y squared is equal to, what's 144 minus 64? 80. And then what do we still have left to do on both sides? And then it says round to nearest 10th. What's the square root of the 80 rounded to the nearest 10th? 8.9. Get as much down as you can. Oh, just keep your book back so that happens. So we take a look at B. How can we find W? Can we use the Pythagorean theorem? Why? We don't know that third side, right? In order to use the Pythagorean theorem, it has to be like A. We have to have two sides of that right triangle in order to use Pythagorean theorem. Well, in B, we were only given one, so we can't use it. But there is a way. The way we're going to use, we can use trig. We can use those trig ratios to help us find this missing side. And we can't use the Pythagorean theorem. If you can use the Pythagorean theorem, go for it. But when you're only given one side, that's an indicator you have to use trig. When you're given two sides, then you can use Pythagorean theorem. So we're going to follow these steps. We're going to write down SOHCAHTOA, or you look at your green sheet, but we're just going to write down SOHCAHTOA. That's going to help you later on in your math career to not have those formula sheets. So we're going to try using SOHCAHTOA. Just like we've been doing, start with the angle. You're going to start with the angle they give you. Okay? Identify your opposite, your hypotenuse, and the adjacent, and then set up an equation using one of those three trig ratios, sine, cosine, or tangent. So if we go back to that example, we're going to relook at that B from that first example and find W. Well, I'm going to start with the angle they gave me. The angle they gave me is 54. That's where I'm going to start. Label all my sides based off that angle. If I go across, we label that side as our what? Opposite. Go to our 90, go across, that is our, and the side left over is G-set. We have to figure out which one we're using. We aren't told which one we're using. We have to figure that out based on what we have. So looking at your diagram, which side has your opposite? W. Which side? Which side has your variable? The opposite, right? Which side has the number they gave us? Hypotenuse. So we are given info on the opposite. We're given info on the hypotenuse. So which one are we going to use? Sine, right? Sine has opposite and hypotenuse in it. So we're going to use the sine ratio to help us solve. To set up your equation, you're going to say sine of the angle, so 54, equals the ratio opposite over hypotenuse, W over 17. There's this little saying we like to use to help us solve. Alright? when the variable is up high, we multiply. Okay? So whatever variable's up high to the top of the fraction, we're going to multiply both sides by whatever's in the bottom of the fraction. So variable up high, we multiply. That way it cancels out, and we're left with W equals 17 times the sine of 54. That's what you're plugging in your calculator. You put the 17 in front so you don't accidentally type it in incorrectly into your calculator. If you have a graphing calculator, I'll show you how to use Desmos, and I'll show you how to use a graphing calculator. If you have a graphing calculator, it's really important. Your mode has to be in degrees. Right? When you take an OSC in the fridge, we have to clear your calculator. When we clear your calculator, it automatically puts it into radians. We don't want radians. Okay, radians is just another way to measure an angle, how you can measure something in inches and you can measure something in meters. That's kind of how radians and degrees are. We primarily focus on degrees. So, to change it back, you're going to hit mode, right next to the second button. You are going to arrow down until it's flashing on radian, and then you arrow over to degrees, so it's flashing on degrees. And then you hit enter. Your calculator is now in degrees. The thing is, when you take the test in the OST, you clear your calculators, it automatically resets back to radians. So you have to remember to do this on your test. Is he picking you up, or you're driving yourself? Sometimes they're very busy, so like, let me finish this problem and then I'll call down. I'll call. Do some math while you're in here. So you have to remember how to do this. Desmos, the testing Desmos, is automatically in degrees. You don't have to remember how to do anything. You just plug everything in your calculator when you take the test using Desmos. I strongly encourage you to just use Desmos so you don't have to worry about doing this. Okay? Because what's happened is you're going to get the answer wrong if you don't remember to do this on your graphing calculator. So that's why I strongly encourage you to use Desmos. To get out of the screen, hit second mode. To type this in on your graphing calculator, you're going to do 17 times sine of 54. And enter. You should get that same amount when you plug it in. Anyone plug in your calculator and not get that same amount? No. Good. So the directions say round to the nearest tenth. So this would be 13 point what?
8.
So the length of W is about 13.8. Okay. For Desmos, test Desmos is automatically in degrees, but if you're using the so if you're not going through Desmos through Canvas, if you're just like Googling Desmos, you have to change it to degrees. So again, I highly suggest you use the link that I have in Canvas for Desmos. That way you're using the test one. But you just click this little wrench up here, the little tool, and then just click degrees, and you're in degrees. A little easier than your graphing calculator. But you type it in the same way. Using Desmos, you would say, what was it, 17 times. To get those trig ratios, you hit functions, and we would just say sine of 54, and we get the same answer, 13.8. I think Desmos is a little bit easier to use. You don't have to worry about changing it to degrees like your graphing calculator. Okay. So I strongly encourage you to use it. Questions after that? So we take a look at B. I'll call down real quick. Thank you. So we take a look at B. Start with your angle. Label, if we go across, that is our what? Opposite. Go to your 90, go across, that is our hypotenuse. Side left over is our adjacent. This time around, which sides have info? Opposite and the adjacent. Hypotenuse, we don't have anything. So if we have something for our opposite, we have something for our adjacent. Which one are we going to use? Tangent. So we are going to say tangent of our angle is equal to tangent opposite over hypotenuse, so x over 15. Again, our variable is up high, so what are we going to do? Multiply. And we're going to multiply by 15. That way it cancels. We have 15 tangent of 39 equals x. That's what we are plugging into our calculator. Okay? So I'll use Desmos this time. We're going to do 15 times, clear out what's in there. 15 times, go to functions, hit tangent, and then you're going to plug in your angle, which was 39. If you use your graphing calculator, you should got the same answer. If you don't get the same answer, you use your graphing calculator and let me know. I'm going to use Desmos because that's what I want you to use. Yes. It's in a totally different terms of measurement. So when we round, this is 12 point what? Round in your tenth is 12.1. So x is equal to 12.1. Done. Questions over that? So here, we're going to find the value of the missing variable. Again, can we use the Pythagorean theorem? Yeah. No. Are there notes on your desk? Okay. Let's follow along with the notes. We're going to find the value of the missing variable. Round your answer to the nearest 10. Okay. Well, again, can we use the Pythagorean theorem for this one? Not really. It was just here. No, we only have one side. So when you only have one side in a right triangle, we have to use trig. Start with the angle they gave you. The angle they gave us was 33. Label your sides based off that angle. If we go across, that's our opposite. Go to your 90, go across, it's your hypotenuse. Side left over is the adjacent. Look at SOHCAHTOA. Which two sides have info? Adjacent and hypotenuse. So which one are we going to use? Cosine. A over h, adjacent over hypotenuse. So we're going to say cosine of our angle, so cosine of 33 equals 4.5 over W. Now our variable's in the bottom of the fraction. Our variable is down low. So when your variable is down low, there's a saying we like to use, switch a row, meaning the W and the cosine of 33 literally swap. This just becomes the W equals 4.5 over the cosine of 33. They literally just trade places. Where the cosine goes, the 33 goes. And then we plug it into our calculator. We're going to do 4.5 divided by cosine of 33. So in Desmos, 4.5 divided by, hit functions, cosine of 33. If you use your graphing calculator, you should have gotten that same answer. I would have Desmos out and practice typing this in too. That's the hard part, is typing it incorrectly. Okay. If you don't type it incorrectly, you're going to get the wrong answer and you're going to lose points. Okay. So we round this to the nearest tenth, it would be 5 point what? 4. Questions over that? If we take a look at B,
Hey, this is Mrs. White.
Circle your angle. Label. Go across. That's our opposite. Go to your 90, go across. That's our hypotenuse. Side left over is the adjacent. Which two sides have pieces of info? Yeah, so which one are we going to use? Tangent. Tangent's opposite and adjacent. So we're going to use tangent. Opposite is 9. Adjacent is x. Opposite over adjacent. 9 over x. Where is x? Up high or down low?
No.
Down low. So then what are we going to do? Switch a row. So this becomes x equals 9 over the tangent of 32. And then you plug that in your calculator. So we're going to do 9 divided by, go to functions, hit tangent. What was the angle measure? 32? You should get that. You will not get that. So when we round, it'd be 14 point what? 4. Questions over that? I divide by the wrong number. Oh, I just wrote the numbers wrong. Questions over that? Well, we can use this to help us find angles in a right triangle as well. So sometimes we can't use that angle sum theorem. We can't use the fact that angles add to 180 to help us find missing angles in a right triangle. Okay, sometimes all we're given is the right angle, but we need to figure out what the other angles are. Okay, so we can use the same steps as finding sides to help us find angles. But how we plug it into our calculator is a little different. To plug it in our calculator when you're trying to find an angle, we use the inverse. Okay? So what essentially we are doing is here, we have the sine of angle A equals 8 over 10. We want to figure out what the measure of A is. A is always representing an angle. To do that, you're going to use the inverse. So you're just going to do sine to the negative 1. That means inverse. And you just take this inverse sign of the fraction or the decimal you are given. So if we want to find A, we just do inverse sine of 8 over 10. And then you plug it in your calculator. Okay? So in Desmo, to plug it in, what you're going to do, you're going to go to functions, and then you just hit the sign that has the negative 1. And then you type in that fraction, 8 divided by 10. That's what you should get. In a graphing calculator, what you are going to do, you are going to hit second and then sign. So the blue second button, and then sign. That gives you the inverse sign. And then just do 8 divided by 10. You get the same thing we plug into Desmo. Directions say round to the nearest 10th. So the measure of that angle is 53.1. So A is 53.1 degrees. Same thing. We want to find the measure of angle B. So we're going to use the inverse of cosine. So cosine of the negative 1. Then type in that fraction. Plug it in your calculator. In Desmos, hit functions, Hit the cosine that has the -1. Type in that fraction. What was it? 7 over 25. Oh, what the heck?
Oh.
And 7 divided by 25. In your graphing calculator, you just hit second cosine. You should get the same answer. So around nearest tenth, this angle is 73.7. So B is equal to 73.7. And then same thing for C. It's a decimal, but we still use the same thing to find Z. We're going to use the inverse of tangent. And then type in that number. So again, in Desmos, you're going to hit the functions button, hit the tangent that has the -1, type in that number. There you go. In your graphing calculator, you should hit second tangent. The blue second button, and then tangent. Then type in the fraction. Or the decimal. So this rounded nearest tenth is what? 67.4. So Z is equal to 67.4 degrees. Questions over that? So, in combination of what we just did and what we did with finding sides, we can use those two concepts to help us find the missing angle. So here, we want to find the value of x, the measure of angle x. So that's what I'm going to start with. I'm finding x. X is an angle. I'm starting with that angle. And then we label. If we go across, we label that as our opposite. Go to your 90, go across, we label that as our. And the side left over is our adjacent. Which two sides have info?
Opposite.
So which ratio are we using? So we are going to say sine of our angle. In this case, it's x. We don't know what it is. That's okay. Equals the opposite over the hypotenuse. So again, the same for when an angle is missing. It's not a curse. You use the inverse. So we just literally do what we did. It's no different. It's set up the same way. So we have to use the inverse of sine. So we just do sine to the -1 of what it's equaling. And then plug that in. Sine to the -1, 6, is it 6 divided by 10? Rounded to the nearest 10th. What's the measure of that angle? 36.9 degrees. We'll skip B. B is just like A. I just want to make sure we go over this next little section. Sometimes we use this variable. Looks like that. It's pronounced theta. Okay? It's just a variable. It represents a missing angle. Theta always represents an angle. Okay? Kind of, it's a circle with a little curvy thing through it. Another little line. It's called theta. It represents an angle. It's no different than x. It's just a special, unique variable. That's all it is. What? So, that is theta. Again, we use theta for angle, so you can see it looks like a little 0 here. So there's a little line through it. That's theta. Sometimes you're asked to find theta. That's no different than being asked to find x. Okay?
Oh, okay.
So you see theta, it's really just saying, hey, find this variable. Round your answer to the nearest tenth. So theta is where angle A is. So I'm going to start with that angle. Label, go across, opposite. So the 90, across, hypotenuse. Other side, adjacent. If we look at SOHCAHTOA, Which two sides gave us pieces of info? The opposite, the what? Adjacent hypotenuse. Which one are we going to use if we have the adjacent and the hypotenuse? Cosine. So we're going to say cosine of theta because that's our variable. That's our angle. Cosine of theta equals. And if it's annoying, you can put x. I don't care. I just want you to know that theta is a variable. So if you see theta and you find it annoying to have to draw, put an x. I don't care. Okay? But just know theta is no different than x. So cosine is adjacent over hypotenuse. So 12 over 13. And the angle is missing. It's not a curse. What are we going to use? The inverse. So we say cosine for the -1 of 12 over 13. Type it in your calculator. Then go to functions. Put the negative cosine. The 12 over 13. So the fraction. Is that right? So when we round to the nearest tenth, it's going to be 22.6. So theta of that angle is about 22.6 degrees. If we take a look at the last one. Sometimes when finding the measure of a missing angle, we are given all three sides of a right triangle. When this happens, you can pick any ratio you want to use. So we want to find the value of angle F. We want to find theta. Well, we know all three sides. Which one's our favorite? Which one do you want to use? Sine, cosine, or tangent? Sine? Or sine first. So we label. Go across. That's our opposite. Go to your 90. Hypotenuse side left over is your adjacent. If someone doesn't want to use sine, use cosine or use tangent. Let's see if we get the same answer as if we use sine. Okay, let's see. Someone do cosine, someone do tangent. We're going to do sine up here. Okay, so we're going to say sine of our angle, which is theta. That's a variable representing our angle. Sine is opposite over hypotenuse. So 15 over 17. The angle's missing, it's not a curse. What are we going to use? Inverse. So inverse of sine. So sine of the -1 of 15 divided by 17. Type it in your calculator. Function. Sine with a -1. 15 divided by 17. Did anyone use cosine? Did anyone try cosine? Did anyone try tangent? Chloe? Did you try a different one? Or do you have a question? Did you get the same answer? She got the same answer. She did tangent. She got the same exact number. Did anyone try cosine? If you tried cosine, you would have gotten the same answer.
Whoa.
So, 61.9. Oh, whole number. So it would be 62 degrees. Make sure you read the directions on what you're rounding to. Questions over that? Okay, there is some practice in there that you can try. We'll have more practice with this tomorrow and then a quiz on